All right, hello, and welcome to our first online lecture. Today we'll be talking a little bit about what science is. Okay, and in order to even begin to talk about that topic, I think we have to understand where we get knowledge from. How do we acquire knowledge? So let's talk about four methods of acquiring knowledge. Let's start off with intuition, which is knowing without reasoning. Okay. It's like a hunch. And hunches can be decent in forming hypotheses and forming ideas about what we might want to research. But the problem with them is that there's really no mechanism for separating accurate from inaccurate knowledge. So let me give you an example of intuition. It might come from an old saying, such as birds of a feather flock together. And that might give you the idea, oh, I wonder if people who are more similar tend to form romantic relationships. Maybe it's true, maybe it's not. And there's nothing wrong with using a hunch like that to start your research, to start thinking about ideas. You just want to then go to the literature, go to other methods of acquiring knowledge, and not just simply conclude, because I've heard this phrase, birds of a feather flock together, that it definitely means that people who are more similarly minded are going to form romantic relationships. Okay, so that's intuition for you. The next method of acquiring knowledge is authority, or facts stated from a respected source. For example, could be news media, books, government officials, religious figures, political pundits. Could be a whole host of whatever are known as authority figures. Okay. Um, Now, authority figures might be useful in the design phase of a study, and they might be useful when you're interpreting your data, but the problem is authority can be wrong. We all know this, right? We all know that just because you hear it from even a well-respected source does not mean that it is definitely truth and definitely something we want to enter into science. Okay, so that's authority for you. Um, let's I'll give you one more example. Even psychological authority figures, right? Even people like Freud, right? He's a well-respected authority figure, but some people definitely vehemently disagree, excuse me, very strongly disagree with some of his points that he made, right? And later on. So authority can only take you so far. All right, let's press on to the next one. Rationalism. Rationalism is knowledge from reasoning. You might want to think about Descartes, who said, I think, therefore I am. Okay, once again, this can be used to derive hypotheses. All right, so it's helpful in forming our ideas about what we might want to study. It might even be used to identify outcomes that would indicate the truth or falsity of the hypothesis. But the problem is, relying solely on rationalism can lead two people to reach different conclusions. Now, here's where I like to bring out my geek side and point to this is a really old episode from Star Trek. And this is actually from the original series. And on the original series, there is someone named Spock, who is a Vulcan. And he is always very rational and very logical. And so you would think that all his conclusions would be spot on. Well, during like I said, one really old episode, they brought out an evil Spock. And the evil Spock would also use rationalism, would also use logic to draw conclusions. And somehow, despite this, he would draw opposite conclusions from our usual Spock. So, this is just a long way of my saying that, just because you are using a logical path doesn't necessarily mean that you're going to reach solid scientific conclusions, okay? Um, so it has its place, and there are actually fields that rely entirely on rationalism. Um, I'll let you think about, maybe think if you can guess what field maybe relies entirely on logic. If you thought of theoretical mathematics, or if you thought of philosophy, yeah, those both tend to, and I'll say tend to, rely mostly on rationalism. Okay, so um, uh, some people say that, you know, that's great for that field, but it's really not what we want to do, except for certain aspects for our field. What we really want to do in our field is rely, at least these days, on empiricism, which is knowledge from experience or experiments. This is when we use observation to collect data in science. Okay. Facts that concur with experience are accepted, and those that do not are rejected. So let's say, for example, you wanted to test that theory that, we'll say, even successful romantic relationships tend to be formed by those who are more like-minded. So you hand out all these personality questionnaires to people who have been married short periods of time, to people who recently broke up, to people who are married long periods of time, etc., just to get that sense of what's going on there. And you find out that actually that's not true. Actually, you know, it tends to be more that opposites attract, and opposites tend to form successful romantic relationships. Then that's okay. You would just now accept the new proposition and let go of your original idea. Okay? And so empiricism has to do with systematic strategies that are used to reduce researcher bias and maximize objectivity. Okay, so that's what we're talking about here. I told you about Descartes before. Now you might want to think of John Locke and the tabula rasa, the blank slate. We're starting as if we know nothing, and we are basing everything on what we collect and what we observe. Okay, and really the biggest danger here is researcher bias, and that's why we're going to use these systematic strategies to reduce that. Okay, and we're going to talk more about what kind of strategies we can use to reduce that researcher bias as we go forwards. Okay. Now, even though I said that we really rely more on empiricism these days in psychology, the truth is you saw with each one of them that I pointed out how you might use it for hypothesis formation or for different aspects of the study. So I don't really want to demonize any of these methods. They all have their place, and they all must be integrated to be truly successful, I think, in scientific investigation. Okay. So from there, now let's talk about what science is. Uh, First of all, science is designed to systematically produce reliable and valid knowledge about the natural world. Okay. It comes from the Latin verb sire, which means to know. So that's what science really is about, I think. I think it's about really a quest for knowledge, a quest for new information. And while different scientific methods have been popular historically, right now where we tend to be, at least in the psychological sciences and the behavioral sciences, in an empirical age. And multiple methods, multiple practices tend to be used. Okay, so what scientists want to do, what they want to, what their some of their goals are, is to be skeptical, to be creative, to be systematic. Okay, so it's good to actually be creative, to have these wonderful far out ideas, as long as you're skeptical and systematic in investigating them. You want to identify problems. You want to question solutions that aren't working. You want to creatively and systematically come up with new solutions and then subject these new solutions to empirical testing. Okay, so that's a little bit about what science is. Okay. So in order to be successful, science also must conduct research ethically. We're going to have a whole conversation about ethics as we press forward. We're going to talk about that together. Okay. We're going to, in order to be successful, science must also critically self-examine its practices to determine what is working and what is not, and engage in ongoing learning and improvement. So you'll know a good scientist when they get to the end of their study and they say, "Oh, now it's time for the next study." Okay, that tends to be how scientists think, because we're always interested in figuring out what didn't work, fixing it, and moving forward. Okay. So now let's kind of talk a little bit about the objectives of psychological research. First, we might want to describe behavior. And there's nothing wrong with a descriptive study. In fact, some of you may choose for your research project to choose something that's a descriptive study. For example, are jurors more lenient with those they perceive as attractive? Are people more likely to be persuaded by someone with high credibility? Both simply just describing behavior kind of studies. Okay. What happens? What do people do given a certain situation? The next type of objective would be to predict behavior. So, for example, maybe we're interested in post-traumatic stress disorder. And what we want to know is what kind of early response to trauma predicts a chronic or long-term post-traumatic stress disorder syndrome. Okay. Because maybe if we could predict it, then we could intervene early on and even prevent someone from developing chronic post-traumatic stress disorder. The next objective might be to determine the causes of behavior. And this is where it starts to get really tricky to determine cause. We'll talk a little bit more about it as we go forward. But to start off, let's just talk about a few things you need in order to determine the causes of behavior. First thing you need is what's called temporal precedence, which sounds kind of fancy, but it really isn't. It means that the cause has to happen before the effect. The cause has to happen before the effect. Okay. So you drop a piece of paper, it lands on the ground, cause was dropping the paper, gravity took over, landed on the ground. Okay, covariation of the cause and effect. What this means is that when the cause happens, the effect happens. And more, just as equally important, when the cause does not happen, the effect does not happen. Okay. So let's take an example of this one. Let's talk about children watching television violence being more aggressive. Okay, so children watching television violence are more aggressive. That's our hypothesis. That's what we want to explore. Okay, so that would mean that when the child watches television violence, that child becomes more aggressive. And children, when they don't watch television violence, are not aggressive. Well, that already is probably ringing bells in your head saying, well, that's not always true. I mean, there might be a child who acts aggressively, even though they're not watching television violence, right? So that's a problem because that gets into alternative explanations. There should be no other explanation for why the effect happens other than the cause. Like I gave you with my first example surrounding gravity. Why does an object fall when you let go of it? Gravity. Right? That's pretty solid. But why does a child behave aggressively? Can we just say it's only because of TV violence? Probably not. And that's where it gets sticky. Not saying that means you definitely can't show anything, but that's where it gets a little sticky there. Okay. Now, let's say for fun, let's get into explanation of behavior, and let's say for fun that it was somehow established that children who watch a lot of television violence tend to be more aggressive. Why? That's what explanation of behavior is trying to explain, is trying to help out with the why. Could it be because of modeling or imitation? Is it because children who watch more TV violence are desensitized? Is it because children watching more television violence perceive that as normal behavior? And these are three different explanations that might come into play with respect to why TV violence might be associated, might cause violent behavior in kids. So as you can see, we're getting a little bit more challenging as we go down the line here, from describe behavior to predict behavior to determine the causes of behavior to explanation of behavior. And I suspect for you guys, for the studies you'll be conducting, you'll stick with the first two, describe and predict. And those are perfectly good studies. Okay. So the last big topic I want to talk to you about today is pseudoscience. Now, pseudoscience is an approach that claims to be scientific, but in fact violates many tenets of science. Okay. And they attempt an association with science to gain legitimacy. Okay. So, in other words, you might have someone that says, it has been scientifically shown that if you were born under the born in November, that you will be more likely to marry someone who was born in September. Okay. Now, maybe that has been scientifically shown, and maybe it hasn't. See, it really has nothing to do with what question you ask. And this is one place where I do disagree with your book a little bit, because it says, things like ESP and astrology, and that's why I brought up the September and November, are pseudoscience. Well, it could be that they've used non-scientific methods to show their truth in the past, but that doesn't mean we can't conduct scientific investigations about it, right? I bet you can imagine a way, if you were trying to actually conduct a real scientific investigation about ESP, there's probably ways you could do that. Okay, so it's really not about the question, it's about the process and the approach you take. Okay, so here's some strategies used in pseudoscience, and you'll see how they're different than science. The hypotheses generated are not typically testable. Well, that's the exact opposite of what we want in science. We want to be able to test our hypotheses. We want to be able to show whether they're true or not true. Now, if scientific tests are reported, the methodology is not scientific and the validity of the data is questionable. Okay. Now, you're going to be spending the next semester learning about how to use scientific methodology and how to have very clean and accurate data. Next, supportive evidence is anecdotal and does not cite scientific references. Oh, I know someone who has ESP, hence ESP is a real thing. That's anecdotal. That's historical. Okay, that's not how we do science. Claims ignore conflicting evidence. This is a big one, and it's really important to be aware of. You know, um, when evidence comes up that shows that your hypothesis is not true, there's no need to hide from that. Just accept it and move on, right? You don't ignore the conflicting evidence, you embrace it. Claims tend to be vague and appeal to preconceived ideas. Claims tend to be vague and appeal to preconceived ideas. And finally, claims are never revised. Okay, so those are the big items under strategies used in pseudoscience. Remember, I just shared with you a few moments ago that claims are constantly revised in science, right? We get done with one study, we're ready to start the next one with a new idea. Okay, so, and again, I know you guys are going to be conducting projects down the line, right? And let's say your hypothesis works out to not work out, right? You don't have enough evidence to show it, or it comes out the opposite. No problem. That's great. You've learned something, and that's what science is all about. Okay. So that is all I have for you guys for this first online lecture. Hope you're all well and stay well, and I'll see you next time.